Hello there. So it's been a while. I'm hoping to post more regularly again in the future. But I had a friend reach out to me recently about parlays and sports betting and whether I thought it was a dumb bet. And I do a lot of sports betting, so I do have a lot of opinions about this. And I thought it would make a good case study of what data science has been like for me in various consulting engagements, what companies sort of look for, and how sophisticated I normally get. Because really, I don't have to get very sophisticated with most companies to do analytics to a level that they're happy with. And data science, a lot of times, doesn't need to be that complicated. But I thought it'd be interesting just to go over my take on this as somewhat of a subject matter expert in sports betting and then looking at it from the data perspective too. So, yeah, let's get started. As always, I got a Jupyter notebook. You can look at the link below the video to download all the libraries and do everything that I'm doing here. So to start with, here's my Jupyter notebook, and the UNLV, that's Las Vegas University of Nevada. That makes sense. They publish all the stats on Sportsbooks, I believe just for the Nevada casinos. And this is the win percentage by sport. This has been updated since 1992, and you can see data all the way through 2022. So my friend looked at this data. There's another category on, there it is, parlay. And you can see that the percent of win by the casino is really high for this one. And everything else is a bit more mixed, a lot smaller. And I thought the data actually made a lot of sense to me with what I would think, going into everything, which was great. But still, it's good to analyze this and sort of show, how a business might want you to do this. So I do a lot of work with PDF scraping. I could automate this data to, write a scraper to read this page of the PDF, extract out all this table information and do all that, but that's overkill. We're only getting one set of data. It's really not much, so we can just copy and paste this and begin analyzing it. So that's all I've done here. I put this in a multi-line string in Python. These 3 quotes, if you're not familiar, makes it go multi-line. And then we can quickly read this as a CSV using pandas. So in here you can see I made things into a string IO that makes the text behave like a file, which helps pandas read it more easily. I think there's a way you can put in a string, but this just worked and it was easy. And then I told it that the separator was a space. So normally you work with CSVs with a CSV, the C is for comma, the rest is separated values. So this does a space separated value. So boom, we've got it loaded right here, which is amazing. And now we can analyze it. So as a data scientist, a client might be like, hey, we have this data, it's a public data source about, I don't know, taxes or businesses that pay county taxes. We want to see which is the biggest one or something. You might have a data set that comes with a PDF. You just need to copy and paste it and do some quick analysis to help them understand the sector more. And the first thing you can do with pandas is just plot it. So you get a feel for all the data. So yeah, parlay really stuck out before, but we didn't really have a good feel for it. And plotting things visually is a great way to understand the data over time. Now, we can see parlay sticks out here, but it's kind of ugly. So let's get rid of that and just show without parlay. Again, this plotting library is pretty terrible. I wouldn't want to show it, I'm almost ashamed to be showing it to you, but this is sort of more educational in nature. Would not want to show this to anyone, in a business setting who isn't really a programmer, because that is very ugly, very hard to read. There's too many data points here for you to look at the legend and refer back to these colors. It's not great. So instead of that, I'm going to use a different library that I like called Altair. It's pretty nice because it's a little more language agnostic, and it you can do stuff in JavaScript or other languages very nicely. And yeah, so we're going to work with that one. And first we have to reformat our data. So you'll notice this is how our data came from the UNLV report. To make it work with most visualization libraries, they like you to make it in this format where you have those top columns listed out in this different schema where you have the variable name and the value for each one. Doing it this way makes it easier for the data to be loaded. To reformat things, there's this nice pandas function called melt. I actually just used it for the first time with this video, so that was cool to learn. But sort of a one-liner to say, here's my ID, it's the year, so each variable will be the same for each year, and then all those values should be sort of normalized like so. So that does that, and we can pass it into Altair. And I did a little work here to make things interactive. Still not the prettiest, but since we're working with it interactively, I think it's okay. I filter things out just to the three main sports, baseball, basketball, and football, and then also the total. And if you hover on this with the chart, I've coded it to use the nearest mouse location to select that line. So if we want to look at baseball, which is an interesting one, we just highlight that one, and the legend updates to baseball. And there's a couple interesting things here. Looking at this, you can see there's a difference between 2004, 2005, and after that time it looks relatively the same. So you got sort of two modes in this graph, and it looks like that holds true for total here. There's a little bit of a difference between, what is it, 98 increasing a bit to 2006, where the casinos are winning more, which is kind of surprising. You would think they would, maybe win less over time, or vice versa, but maybe some consolidation or other things led to that. But yeah, so that's interesting. And then if you look at other sports, the effect is a little bit muted compared to baseball. Like football looks mostly flat, maybe a slight increase in casino 1%, but baseball is by far the most dramatic. Now, if you were working with stocks or much more quantitative data, you would design some statistical tests to analyze this, but there's not many data points, and you're just trying to explain something real quick. So, someone in a business perspective, someone who reads your report and is like, okay, what should we do about this? They would probably want to understand what's the difference between baseball before 2004 and after, and then what does it say about casinos as a whole? So here's my take at that. Again, this isn't very sophisticated, but it's been my experience that when someone wants something analyzed, they might want you to whip out some fancy tools, but at the end of the day, they want a simple explanation, and that's normally the best. If we only have 30 data points, you can't do too much stats on this anyways. So I've written this all out. It's kind of ugly, but I'll just sort of summarize here. So baseball was the worst sport for a while for casinos. And in my opinion, there's one unique thing about baseball from all the other sports, which is the sabermetrics movement. If you haven't heard about that, that's where all the statisticians focused on, not all of them, but a lot of them, focused on baseball, because it was a sport that you could easily enumerate all the states. Who's on base, who's up to bat, is the pitcher righty and lefty, and to more basic analytical approaches, those all seem like they would mean something from baseball understanding as well, like a lefty pitcher and a righty hitter and vice versa. There's lots of different interactions there. So it was analyzed pretty well, and I think it makes sense that casinos would actually do worse on that one because there's a lot of spread in skill. Where a sportsbook is trying to match up people who have two bets and they're just trying to get the fee generally. So sportsbooks are best thought of as a market maker where they want to have a balanced book on each side as much as possible and just make money through their fee. Of course, it doesn't work out because people like teams and all that, so they try to find some maximal point where they get the most profit, of course. But loosely, they're not trying to pick the best team; they're just trying to make the most money. So I think it would make sense that, because there's a lot of unsophisticated people and sophisticated people in baseball, that that one is one of the worst ones. So that's my explanation of baseball. I think in a business setting, you show someone this chart, they would agree with you, yeah, baseball's special. The one main special thing about it is probably sabermetrics, so that makes sense. Done. Second thing, overall win rate is around 5%. And that one's kind of interesting. One thing I found from human behavior, and this would be my explanation, is people like being right more than they like making money. And sportsbooks charge a little fee on everything. And that fee sort of averages out to around 9% on the winner. So it would make sense for people to bet on the sports if they think they can beat or be correct, but it has to be correct a little bit more than random guessing. So that's why it's better than, or worse for sportsbooks than 9%. They're winning a little bit more, but not by much. So that kind of makes sense to me. That's why it's that number, not like 20%. And then there's one more thing. 1997 to 2005. This was something I was probably the most shaky about. And when this happens, if you're showing this to someone in a business setting, depending on how much you're sort of on the same team or not, you might try to find holes in your analysis ahead of time or not. I think the most obvious thing, 1997 to 2005, was that the internet was adopted, and that made a lot more efficiencies within sports betting. People had access to data. They could see things in real time, how scores were happening, and then analyze it more easily through personal computers. So that's my explanation of that, but it's not the best, I would say. So like if you were showing it to someone who wasn't on your side, you might want to figure this out ahead of time. But if you're working within your own company and you're trying to spitball ideas, that might be something someone comes up with. And then a quick look at the stats does show it's our world in data. Internet adoption, the green line is North America. And we can see a really steep adoption rate from 1995 to 2005. And then it sort of flattens out for a bit. And to me, that kind of lines up nicely with what we see here, this sort of regime where things are increasing in terms of better for casinos from, you could even argue, 95 to 2004, etc. So it kind of makes sense, but maybe we want to look at more things here. That's something we're a little bit more shaky on. And another idea would be consolidation in sportsbooks. Maybe they charged higher fees as time went by. That's why they're making more money. That's a more direct answer. And that's one thing we could look at too. So oftentimes in homework problems or like a Kaggle contest, you're trying to use the available data to come up with the best answer. But in a business setting, it's always, well, if you need more data, should we pay for it? Should we analyze it? Should we try to get it? Where can we get it? What can we say? So in this case, I just needed to go find the data. So I had to be a little creative. I wanted to analyze how payouts have changed with sports bets. And the spread bets are one of the most common ones in the NFL, which is the most popular sport in betting. And just a sec. And with spread bets, the payout is normally minus 110. So for every dollar you put in, you get 90 cents, 0.9 cents back. It's sort of a repeating fraction. And I wanted to see if that happened over time. If that used to be minus 115 or minus 105 and then changed in recent years. And when you Google this data, part of my argument before was people like being right more than they like making money. You'll notice that, let's say like Super Bowl odds history. So we look at this Sports Betting Dimes website. They show you what the spread estimated was, so Philadelphia minus 1.5 for the Super Bowl, and then what happened, who won. But there's one very important piece of information missing here, which is the payout. On a spread bet, most people would assume it's 110, but has it always been the case? No. DraftKings and FanDuel are trying to be a little bit more competitive, so they might even do like 108 or 105. It really depends on the book, but people don't focus on that. They're just focusing on who won the bet. And that's everything that's wrong with sports betting, because people are not being as analytical as they should be. And that's why spread betting is so popular compared to money line, where you have to look at the probability of it winning versus your expected probability. And people aren't very good about deciding between 60% and 55%, so it's not as good. Anyways, that sort of reinforces what I was saying before. But to answer the question, how do we look at the odds history? Well, I was thinking a little bit, and another market that would show that is the futures market. People do look at the odds to win the Super Bowl a lot, and I did find on Pro Football Reference this great page here. So this is 2005 NFL preseason odds, and here they are. You can see the payouts for each team, and I believe this website will tell you actually when it was sourced, and this is who they get their odds history from. But a great skill to have as a data scientist is the ability to just pull in data really quickly and easily. And that's all that I did here. So I wrote a quick for loop for each year in our comparison set. 92 to 2022 is pretty good. I think it was actually 1992 to 2020 that we have from UNLV. But anyways, I'm just going to grab each one of those pages and then scrape it. To be respectful, I added the sleep function so I don't hit Pro Football Reference like a ton of times. I give a 2-second break which is a little bit nicer. I'd recommend always doing that if you can. And then I separate the polling from the parsing because your parse code probably has breaks, and we don't want to overly request this from Pro Football Reference because they're nice people. So I've got that. And here's the code to parse everything. Let me show you this, a little bit more broken out. To parse things, I think I've shown this in other videos, but you get, websites are made up of HTML. Looks like this googly gook. Then you can use something like Beautiful Soup to parse it and make it a little prettier. So here we can see Beautiful Soup representation of things. And if you're analyzing data, let me pull that up. Or if you're pulling data, what you want to do is use inspect element to analyze the page. If you just inspect this, right click inspect, and then you can see where the data comes from. We're trying to find a table, and Pro Football Reference gave this table a nice ID that should be unique, the preseason odds, and we can just tell the computer go find that and then extract the data. So that's all I wrote here. Find preseason odds, T-head is the table header, find all the table headers. That gives me the column names. And then within each table, take the body, take all the rows, and then these TDs are the row cells. Now I didn't parse the team names because I didn't need that, but I just want to get the odds by year. Okay. So now that we have that, we can look at this futures market and see the aggregate hold, how much the casinos are charging. So you couldn't just bet on every single team. Because if you could bet on every single team and make a profit, then that's free money, that's arbitrage. So they don't want to do that. So if you look at the implied odds at each bet, that's the odds you need to win that bet. The percent of probability of winning that you would need to make that bet profitable. At minus 110, that's 52.38%. And this is the formula to get it. And I go over that a little bit more just below this. But we can see the implied odds. And then here I just do a quick group by year, sort by the implied odds summed, and then plot it. And we can see that the implied odds have actually gone down. So what that means is that the sports books are becoming more competitive even. There was a bit of a blurb in 2010 to 2020, but beyond that, it's a clear decreasing trend. So the justification for sportsbooks winning more money from 95 to 2005 is not that they started charging more. Based on this, you can see that clear decreasing trend. And again, depending on where you're working and how much data you have, you could look at this data much more sophisticatedly. You could do special tests to say, what is the expected slope? I mean, you could do that, but if you're trying to convince someone who's non-technical what to do, all they're going to do is just draw a little line in their heads like this. And that's essentially a root mean squared, minimizer on a line, linear regression, and it seems to make sense. There's not any clear outlier, so they would agree with you. And that's really the extent of it. Yeah, it's a little bit less sophisticated than you'd think. There are companies that want more data science, but a lot of times, a lot of methods are overkill. I'll talk about that more a little bit later. Anyways, here's just a better example of how implied odds work. If you just Google implied odds, I like using the calculator from the Action Network to check bets. And then another thing with parlays is sometimes books let you bet on a parlay with correlated events. So like the odds that one team wins and the total points. That can be correlated if a team is really good at defense. Their odds of winning correlate highly with a low-scoring game, especially if they have a poor offense too. So some sports books would actually let you bet on that, but they take a decent chunk of your odds away. So if you want to make sure that isn't happening, you can go in here, put in a parlay, and then say, here's 2 even money bets. What are the implied odds? Why is this not showing me that? Oh, this is showing me what should win. But you can see if you were to win 2 bets that were plus 100, so you put in $1, you get 2 back. The expectation of winning that is that you want to win that. The implied odds would be 50%, and multiplying that by 2, or multiplying that, or squaring that, to having both hit, both uncorrelated events, you would have a 25% chance of winning. So that's 300 over 100 plus 1, and then the inverse of that, so 1 over 4, which is 25%. That lines up perfectly, so you want to check that your betting odds follow that independent event multiplication. Otherwise, you could be getting screwed on the correlation. And a lot of parlay bettors do not do that, so that's part of the reason parlays are potentially not as good, because some books might do that. But even still, assuming that that isn't the case, I think the reason that parlays are so profitable can be easily explained. So here you go. Here's a chart of just the parlays. You can see this data is pretty much constant, somewhere around a 30%, if you were to draw a line across that. Slight bumps, but nothing major. And it's really not driven by any of the other effects. And I think that really does line up with parlay bettors are not very sophisticated. I wrote quite a bit about this. I'll let you read that. It's in my GitHub. I don't want to sit here and narrate everything to the T. But my take on parlays is very similar to the lottery, that people focus on a parlay bet to win a lot of money. And they do that when they're feeling hopeless or just don't think the money will really matter. So let's say you bet $100 or $90 on something, you lost, you got $5 still in your account. You might put in some crazy bet that you could win $10,000. That's the way a lot of parlay bettors bet. They focus on the to win, and they try to use that to make money, but over time it adds up. So, just like a lottery, people make dumb bets, and that's why parlay betting is so good for sportsbooks. I don't think parlay betting in and of itself is bad, because just like everything else, so long as the payouts are the same, you're just doing, what's the word about that? Trying to just correlate multiple events together to win more money in a concentrated bet. It's just that really attracts dumb money who are trying to win on lotteries that they can't adequately price them out with the probabilities. So that'd be my take on parlays. Again, you might say this isn't really data science. Maybe it isn't, I guess, but it is practically what happens when you present what your analysis is to a company. If you use some fancy neural network to predict something, someone's going to want to know, what is the network thinking, how is it biased, how is it trained, and at the end of the day they want a simple explanation to tie that to something. And a lot of times people, if they don't agree with you, if it's really shocking, you need data to back that up, but it has to be simple, it has to be very explanatory. There are domains where that's not true, but in my experience, most companies that employ data analysis and science want something more like this. Of course, you can layer on the fancier methods. Anything else? This is kind of it. So this has been my experience with data science. Someone might give you a problem, you need to figure out how to explain it, and you want to do it as simply as possible, but also really respecting the method of how you got to that point. If you start analyzing data too much, like a lot of people do with the stock market, you could make up things. You could overanalyze it, because when there's limited data, you really can't spend too much time in there. Otherwise, you're going to start becoming hooked to an idea and getting very, very tied to things. So just something to be mindful of. The best explanations are normally the simplest, Occam's razor, and be careful about that when you do your analysis. Essential skills for data scientists: pulling in data, quick analysis, quick plotting, and just critical thinking on, how does this make sense? This is clearly decreasing, You don't need to do anything more to say that. And yeah, thanks for watching. I hope this wasn't too dry. Please read the Jupyter Notebook, and yeah, have a good one.